Hello, so this is number 9. It says a turntable is initially at rest, is set in motion with the constant angular acceleration alpha. What is the angular velocity of the turntable after it has made one complete revolution? Okay, so this is really just a kinematics question, but it happens to be an angular kinematics question. Okay, so what we want to do is write down the variables we know. We know that alpha, that's my acceleration, my angular acceleration. I know that omega naught, my initial velocity is 0. Okay, and then I know that it makes one complete revolution. Okay, so my theta, how much distance, how many pi's do you have if you do one complete circle, right? I go one complete circle. How many pi's is that? 2 pi's. Okay, so that would be 2 pi. Okay, and then I'm looking for the final angular velocity, so omega. Okay, and so now you want to think back to your formulas that you've seen before, just your regular kinematics formulas, and we have something like this. Which formula would you use? Hopefully this would remind you of something that looks like this. V squared equals V naught squared plus 2a delta x, right? So that would just be omega squared equals omega naught squared plus 2 alpha delta theta. Okay, so now I just need to plug in and solve. So I have v squared equals, well, my v naught is 0, so that part is just going to go away. Sorry, wrote that as linear, not angular. So omega squared, omega naught is just 0, so it'd be 2. Alpha is just alpha, and then theta, delta theta is 2 pi. So equal 4 alpha pi. And then I need to take the square root of that, and so omega will equal 4 alpha pi, and so that would be C.